Got another tag team presentation here. I'll kick off with some general stuff, and then I think Mike's going to come on and explain to you guys what United has in store and what they're hoping to accomplish with Lake Piru. So, monitoring programs. Why monitoring? Basic question. Why are we going to do that? Then we're going to talk about sampling considerations. Kerry already took and talked about a little bit of those. I'll take and throw a few more at you. And we'll talk about a couple of the survey methods used for monitoring, okay? And then reporting. It's great to do a monitoring program, but if you're not telling anybody that you're doing it, then why do it, okay? So reporting is very important. So, the first question, why monitor for quagga and zebra mussels, okay? Well, the first and most important thing is to initiate an eradication strategy for quagga zebra mussels before they become well established or widely distributed, okay? You want to have a monitoring program in place so you can minimize the spread of quagga zebra mussels to other water bodies, and also gives you an opportunity for early implementation of control and eradication measures, and it's required by the state of California. So there you go. For no other reason, you have to do it whether you want to or not. California Code 2302, as Jennifer pointed out earlier. You need to have a monitoring program in place for your water body. Okay, so do you need to monitor? Okay, this is a very basic question, okay? Basically, is your water body at risk? Okay. Does it have access and exposure to vectors of introduction? There's a number of water bodies in the state of California that don't need to have a program because they are closed to public entry and they have no external source that's contaminated with quagga mussels that would result in an infestation. So they don't need to worry about it, okay? Unfortunately, most of the water bodies in the state of California, or fortunately, if you're a recreationalist or a fisherman, they have mandates and uses in place that allow for public access and recreation, okay? And this is important. So, you need to know, you have vectors of introduction. Okay, also, the environmental parameters of your water body, okay? Kerry pointed out some of those earlier, you know, calcium, pH, water temperature, salinity. These are some very basic water parameters that need to be in alignment for quagga mussels and zebra mussels to survive. Unfortunately, just about every reservoir and water body in the state of California, with maybe a few exceptions up in the High Sierra, falls right perfectly within this range, okay? So if you want to know whether or not your water body or any water bodies in your watershed are suitable for those, check with your local fish and wildlife contact. They can tell you what you need to know, or give Kerry a call. She can tell you as well, okay? So, do you need to monitor? That's a basic question, something you need to ask yourself. Okay, sampling considerations. Okay, things to think about when you're getting ready to set up your monitoring program. Okay, you need to identify what your goals are. You need to identify what life stages you're going to focus on for monitoring. You need to identify when you're going to sample and how often you're going to sample. And you need to make sure that you have the right permits and permission to do sampling in place before you begin your monitoring program. So, your monitoring goal basically determines when, how, and why you're going to be doing your sampling. There's two types of monitoring programs out there, okay? One is early detection monitoring. You have a water body that does not have quagga mussels in it. You're monitoring to find out if you get an introduction, okay? The other type of monitoring, which is now in the folks at Lake Piru are currently involved in, is evaluation monitoring. What Kerry's doing, what the biologists at United are doing, they're looking at the population they have in Lake Piru, trying to get a handle on the life history, what those organisms are doing, when they're reproducing, how often they're reproducing, and how long they are, so they can get an idea of what the life stages are at different times of year. The idea being that if a control action is taken, they'll know when to be instituting that control action so that it's most effective. So that's what that evaluation's involved. Okay? So basically, your monitoring program, if you're doing evaluation, that's one thing. If you're doing detection, Okay, what you're basically trying to do is your goal is to detect an infestation at its earliest possible stage. Okay, that's going to tell you what type of monitoring program you're going to want to put into place. Okay. So you saw this earlier, the life history cycle for quagga mussels. When you're trying to target a life cycle, okay, you're going to use different methods. You're going to use different equipment. How often and how frequent you sample is all going to be different depending on what you're trying to target here, okay? Again, the life cycle, the planktonic life stage here, free swimming in the water column, the benthic life cycle here, juveniles, adults, when they're actually settling out, attaching to things, okay? Those are the two basic life cycle, life history forms that you're focusing on for your sampling. So, very simply, okay, when you're going out and you're sampling, you're looking for adults, visual survey. You're feeling for juveniles. They're very small, difficult to see, but you can feel them on a surface. And you're sampling for veligers. You're going out and collecting water samples. So we'll get into some of the techniques and things that you need to deal with that. When you're sampling and how often you're sampling, again, life cycle, you need to determine what that is. You need to look at your temperatures, influences of spawning. Frequently, most cases of early detection generally coincides with spawning season. When they're spawning, you got free-flowing veligers. You're not finding all the adults. They're not very prevalent in a reservoir at the time, but you can find veligers very easily, okay? So it coincides with spawning. And when you're finding juvenile and adults, generally after the peak of spawning, when they're already settling out, you can locate those fairly easy. Permits and permission, something to think about here. You don't need to have any permits to examine, okay? Keyword is examine existing and deployed substrates. You can go out and look to your heart's content. You can pull stuff out, you can look at it, you can determine if something's there, okay? The key word is, however, collection. Okay, if you're going out and you're taking substrates out of the water, or you're taking things out of the water and you're taking it to a lab for analysis or things like that, you need to have a permit to do that, okay? As Jennifer pointed out, you don't want people moving these live organisms or dead organisms around the state. So as long as you're looking at it in place, you're good to go. But if you're going to be collecting things, you're going to be collecting plankton samples, you're going to be taking your settlement plates, taking them to a lab for analysis and review, you need to make sure you have the appropriate permits in place. Contact California Department of Fish and Wildlife, Jennifer or Eloise back there. They can get you set up and help work with you on getting the proper permits that you can move forward and do what you think you need to do for your monitoring program. Okay, survey methods, very simple. There's three quick ones. Existing substrate, artificial substrate, and then plankton surveys, okay? We'll just do it. Existing substrate, basically you're going and looking for juveniles and adults. You're out walking the shore, you're walking the docks. You're trying to find and see what's, oop. You guys hear me better now? Okay. Sorry. You're looking for juveniles, you're looking for adults, things that are out there, okay? They're on the rocks, they're on the docks, type of routine, okay? Site selection, where are you gonna look, okay? Most effective, you need to go in areas where there's low light, where there's some water current, not something really hard flowing, something that's moving enough that bringing food and cleaning out the waste products, so they're gonna be there. Other considerations, high risk areas. You're going to want to do your stuff at the point of most likely you're going to get your initial introduction. That's going to be around boat ramps, okay? That's your most likely vector of introduction for a water body. So you're going to want to look there. Shaded side of permanent structures, something you can see easy or reach easy, and something that's accessible and safe, okay? You don't want to be going around the intake structures on the facility and get sucked downstream. So you want to make sure you know what you're doing when you're out there doing that type of stuff, okay? So methods, very simple for existing substrate. Again, visual, you're out there, you're looking for it. It's really high tech, hard to do, but you're not likely to find them up in the trees like these guys, but depending on what you're looking for. Others tactile, getting out there, getting on the dock, laying down there, actually feeling the bottom side of it to find out what you're doing. And then underwater, diving, that's another one. This is high tech. This is not something most likely you're going to be doing, but it is something that if you do have a maintenance program in place on your water body where you use divers, it's good to contact a company, a dive company that's knowledgeable of quagga mussels, knows what to look for, and will do that for you. And a lot of those companies will do that. They're aware of the issue. They have some very highly trained people that know how to look for these things and to find them early. I encourage you to find a company that's engaged with the issue and the problem. So, again, tactile, it's very effective for detecting small juvenile mussels. You can find them fairly easy. Basically, you're down there, you're laying down, you're feeling along the bottom of the dock or whatever. You can see them, you can touch them. They're very easy to find. Once you know what you're looking for, it's real simple. It's not hard to do. Small mussels, they just basically feel like small grains of sand that's on a smooth surface that you wouldn't expect to find there. Okay, you'll find snails and things like that on there, but when you're moving your hand on there, those will flake off. Very easy. They disappear, they come off. Large mussels, you know, they rotate. Small mussels will rotate. You'll feel it there. You can take and put your finger on it and you can go like this, and the byssal threads will allow it to rotate, and then you can be fairly certain that you've come across a dry-seated mussel that way, okay? Okay, artificial substrates. Okay, why would you want to use artificial substrates? You've got plenty of stuff there. Okay, well, a lot of reservoirs, there's not a lot of accessibility for a lot of things. You know, the sides are steep, it's unsafe to be there, you don't want to be around certain intake structures, things of that nature. And also, too, if you're doing evaluation type surveys like they're doing on Lake Piru, where you want to try and get an idea of how frequently they're spawning, when are they settling out, what type of densities are we talking about, you want to have something in place that you can look at and you can quantify. Okay, we put this substrate in on day X, we pulled it 4 weeks later, and we've got X number of quagga mussels. Okay, artificial substrate stuff is good for that because you know when it was put in place and you know when you're taking it out. Okay, and you know when you're targeting different life stages, you can be more effective at collecting certain things. For instance, if you're looking for juvenile mussels, filamentous substrates, you know, scrubs and things like that, that's where a lot of the juveniles will settle out quickly. You don't necessarily need to use the kid's scrubby toy or whatever, but 3M pads or something like that works just as well, because the juvenile mussels will settle out on those type of substrates very quickly, okay? If you're looking for juvenile, you know, larger mussels, adult mussels, hard substrates, a lot of the stuff that you've seen, the plastic PVC plates, flower pouch, things like that, they're a more effective type of substrate to use. Whole range of things that can be used here, concrete, plastic, they'll live on anything. So, you know, wood, steel, aluminum, they don't live on copper. You might as well give up on the copper routine. Unless the homeless folks will steal all your substrates too and go sell it for, you know, whatever. They might do the aluminum too, so you might want to pass on that one as well. But anyway, so a whole range of different substrates to be used. And then deployed. There's a number of ways you can deploy these substrates. It all depends on the question you're asking and the answers you want to get, okay? Most often they're attached to buoys or docks and things of that nature. There's a couple of deployment scenarios. A single substrate down here, you know, they're down. You need to get down below the light level, okay? That's otherwise, if it's up here, they're in the light where you can actually visually see them. Use a Secchi disc or something like that. If you can see them, then you're not going to get settlement, okay? You need to be below the light level in order for it to be effective. So, you know, that's what we've got down here, a weight, substrate, multiple substrates, different things. Another way to do that, if you wish, you can go under a dock, something like that. It's just some ideas, horizontal substrates, multiple substrates, single substrates. And they settle out. And frequently, as has been pointed out, they like to settle out on the rope. We've had a number of instances where people have gone and deployed substrates and get nothing on their substrates and have their ropes covered with critters. So go figure, right? Anyway, so there we go. So moving on. So those are the substrate type artificial and natural substrate type methods. And I want to talk plankton. Okay, plankton focuses on the free form, the free water column, free swimming, if you will, life stage, the villager life stage. Okay, these guys are little, microscopic, very, very teeny, invisible to the unaided eye. If you're good enough, they say you can see them, but I have to wear glasses to read, so let alone reading that, I'm not going to be identifying these tiny little microscopic specks in the water. So generally the identification is through microscope for that. So plankton surveys. A few things you need to consider for plankton surveys. Again, like I mentioned, you're going to be taking things out of the water, you're going to be taking it to a lab for analysis, you're going to need to get a collecting permit from the California Department of Fish and Wildlife, okay? You can collect plankton tows either along docks or you can use a boat to do a plankton tow. There's two ways you can do that. Be sure you get permission from the people to do that. And also safety issues, okay? You're going to be in boats, you're going to be in docks, you're going to be pulling nets, you're going to be pulling ropes, okay? You need to be safe when you're doing that. It's amazing how much trouble you can get into real quick with ropes and water. Okay? Plankton survey, there's basically two types of tow. One is a horizontal tow, where you're like towing it along a dock, or you're towing it behind a boat, okay, as you're moving along. And another is a vertical tow, where you basically lower your plankton net all the way to the bottom of the reservoir, and then you bring it up at a relatively quick rate and collect things that way. Both those types of plankton tows will give you different types of information you can use for different types of analyses, okay? And that's a little more high-tech than we want to get into right now, but Carrie would be glad to discuss that with you later at the break if you want to do that, okay? So, plankton surveys, they're a little more complex, they're a little more involved than doing the other type of surveys. Just to give you an idea of what you're going to be needing to effectively do this, to come up with information that you can use, just give you an idea. You're going to need things like GPS, you're going to need sample jars, ethanol, things like that to preserve your samples. You're going to need the tow rig. You're going to need spooled and marked line for your plankton tow. You're going to need a plankton net, okay? Well, one with a closure valve at the bottom. Make sure you close it when you do it, otherwise your sample just flows right out the other end. We know how that works. And cooler with ice to preserve your samples when you take those, so you can take those to the lab to work on. Decontamination materials, okay, we were talking HACCP, we were talking decontamination earlier. When you're out there sampling, particularly if you're sampling in a contaminated water body, you're going to need to decontaminate all that equipment that you just drug through the water that's full of quagga mussel villagers, okay? And then data sheets, okay? California Department of Fish and Wildlife has all kinds of data sheets on their website that Jennifer pointed out. We'll point that out again to you. All the information you need, data sheets, how to report it, is all there and it's all available, okay? So after you've collected your plankton sample, what do? We take it to the lab and they do what they call PCR analysis. Basically, it's a DNA run. They take a look at that and they look in the water and the stuff you supplied and they look for DNA from quagga mussels. They find it, it's called positive, and they say, you've got a problem. And you go, okay, fine. And then we take it out and you look at it through a microscope. You can do either or both of these. Okay, you're looking at it in a microscope, looking at it, and as Carrie pointed out, under polarized light, you get these little cross hairs, Maltese cross type looks for the quagga mussels. Okay, here they are without, here's the polarized light. This is small, it's not a quagga mussel, and you see the polarized light doesn't affect it. Okay, and that's how they do that analysis there. So generally when they get a positive hit on the PCR, then they do a visual inspection with the microscope to make sure that there hasn't been a false positive thrown. And we've had a number of those in Nevada over the past few years, okay? So, you've been doing monitoring, okay? You've gone through the work, you've done all the stuff, now the rubber hits the road. You need to pass the information on to California Department of Fish and Wildlife. They have a database in place, okay? So you're monitoring and you're not finding anything. Okay, if you're not finding anything, it's important that you report that as well. No No findings are just as important as finding something. Okay, so pass that stuff on so that they can put it in the database so they know who's monitoring what and where. Okay, this is very important information. A lot of people overlook it, but it's very important to have. Okay, and if you find quagga and zebra mussels, immediately notify the state of California. And here's the California hotline right here. Or you can call up Eloise, and she'll come running right out to look. So there you go. Okay. Okay, additional references. Carrie pointed this out earlier. This is the Early Detection and Monitoring Manual for Quagga and Zebra Mussels developed by Sea Grant, California Department of Fish and Wildlife. Okay, important to have. Here's some more references. Here's the website, California Department of Fish and Wildlife website, quagga mussels. This is an outstanding website. It has all kinds of information there for you. Not only how to set up your monitoring programs, your prevention programs, it has your monitoring forms, data forms, it has references, it has the stop a mussel. Video is on there. Just about anything you could possibly want to know about quagga mussels or references is available at that website. It's invaluable and very worthwhile checking that out. And any questions at this point? Okey-dokey. That's okay, I need the exercise.
Yeah. If your pH range is outside of the 7.5 to, I think it was 9.1 on the slide, does that mean you're out of quagga danger?
No. Okay, the pH issue has been a point of contact for a while. They can survive in lower pHs, more acidic water. The problem is it begins eating away at their shell. They're not as effective at forming shells. They can survive in waters within that pH range and lower, but they don't build up and become massive mats of quagga mussels. They can survive, but not very well. Okay, so you're not totally out of the danger. When you're talking really, really low pHs, then they can't establish. A good rule of thumb is if you've got like spring snails or things that are very delicately shelled and they're surviving in your water body, quaggas will do just fine. Okay, something to think about there. A question? You can't ask questions. You're a presenter.
I just wanted to mention that some of our recent experiments have shown that the water depth for monitoring isn't necessarily associated with the amount of light. And we think part of that is because your substrate is providing shade. So anyone who's doing monitoring, if you want to talk more about that, see me later.
Okay. Okay, with that, I'm going to tag team off to Mike.
So I'm going to quickly describe a little bit of the monitoring that United has been a part of, and it really could be split into two components: what's going on in the lake and then what's going on in the watershed. To date, we have participated with Eloise in a couple of surveys outside of Lake Piru. We went with the Fish and Game dogs up to Middle Piru Creek and looked for quagga mussels there, and we also searched a bunch there, and we did not find any. We've regularly looked at the Piru Creek confluence, which is the other piece of property that United owns, and we have not found quagga mussels there. And we've also looked at the hard structures of the Freeman Diversion, and we have not found quagga mussels there. All these red dots here, that's all Lake Piru and just below Lake Piru, and those are all of our monitoring sites at Lake Piru. What I would like to see, and one of the reasons we're having this event, is I would like to see more of these yellow dots as we go downstream. And so that's one of the things that we'd really ask people this afternoon who may have land or property downstream. We'd like to work with you in trying to expand our monitoring program. So our future monitoring plan is currently on Tony's desk, and it involves both downstream monitoring and veliger sampling that we just described. And To date, we have done some downstream monitoring, but that's going to be substantially expanded when our monitoring plan is approved. And villager sampling has not yet occurred, but it's something that we're definitely eager to do. Our current monitoring program has been quarterly dive surveys to quantify the population density and distribution. And you can see there have been a lot of dive hours that have gone into Lake Piru so far. And some of those surveys also involve removing the mussels from some of our facilities.
And Mike, I think it's worth noting that number of 290 dive hours and 268 dives is much higher now. We've done 2 dives already this year, which is about double that now.
We've also been, I think since 2013, performing monthly water quality monitoring, and we're doing a number of vertical transects within the lake at a couple of different sites. And I'll show you a little bit of data. We've also collected some calcium data. As you might imagine, the calcium data suggests it's just fine for quagga mussels. We have performed regional surveys. Currently, our settling substrates that he described earlier are all just in Piru and just downstream in Piru Creek, but we would like to expand that, and that's, again, one of the things we'd like to talk to you about this afternoon. And a lot of the data that Carrie was presenting is a result of these substrate sampling. So the big questions are, how are quagga mussels growing in Lake Piru? When are they recruiting? When are we seeing reproduction going on? As you could see from the data she presented in other lakes, it's variable throughout the state of California. We don't have a great sense exactly what's going on in Piru. You know, we've been in the middle of warm period, not very much water in the lake. Things could really change if the lake is full, the water's cold. The lake's been basically warm basically since quagga mussels have been discovered. So the conditions could be different, the population could be different in the future. So monitoring is a really key part of understanding what's going on in Lake Piru. And I just wanted to give you a little bit of information. I'm going to walk you through this because there's a lot of lines here. This are the results of one site within Lake Piru where we're doing vertical transects with a water quality monitor. Each of the numbers here is a month. The vertical axis is depth, so here's the surface. As we go down, you can see the lowest point is only 60 feet. That's because that's how deep the lake is right now. And in this panel is temperature, and in this panel is dissolved oxygen. This red dotted line here across is about the location of where we get a thermocline, hemocline form. So that's where there's a temperature split in your lake due to the different densities of cold and warm water. Quagga mussels do just fine above 11C, and they can reproduce above 11C. And you can see that basically even in January, the water temperatures, at least in the couple of years we've been monitoring, have been within that range. The interesting thing that happens is when you get a thermocline or a chemocline happening, the way oxygen gets into the water is through diffusion at the surface. If you don't have mixing of your water, dissolved oxygen is being consumed by things that live down deep, but you don't have oxygen exchange bringing new oxygen down to the bottom. So you get a lot of consumption going on, no production of new oxygen, and so you get big declines in oxygen as you go down. And typically 4 to 6 milligrams per liter is considered detrimental to living things, and that's part of the idea of the tarping project, is reduce the oxygen levels so things can't breathe anymore. So that's all the monitoring information that I was going to present to you, but I'll be in one of the breakout groups. I'd be happy to discuss any of the monitoring we've been doing. Oh, I guess I do have a few pictures. You've already seen what the settling substrates look like, and some pictures from our dive surveys.
There was sufficient rain to release 200 CFS for a number of days. That water went considerably past Freeman diversion, all the way through the critical riffle and all the way to the estuary. Have you done surveys below Freeman for any spring-fed waters that may have been contaminated by that release?
No, we have not.
So may I also add, that water did not make it past the Freeman, did it?
Yes, it did.
Was there was a short
Yeah,
release?
yeah, there's migration release into the ocean.
It was about 4 or 5 inches of critical
Yeah, that's right, there was a short release.
But no, we have not monitored downstream.
Okay, that's good. And we got one more. Go ahead and spool that one up.